Hello everyone, I welcome you all again in the journey of mathematics learning. So in the today's video, we are going to cover the fundamental theorem of arithmetic, LCM and HCF, problems related to LCM and HCF, especially related to CBSE Class 10 for upcoming board examination 2025. So first, these things comes under the first chapter, real number. So real number has a very important sections: fundamental theorem of arithmetic, proving the irrationals, and next is problems related to LCM and HCF. So for that, first thing that we are going to see here is fundamental theorem of arithmetic. We already have done this. We already have learned about the composite numbers. This theorem is based on composite number. Any composite number, you can get it out, or any composite number you can take as an example. That composite number can be written as the product of the primes. So statement says that every composite number can be expressed or factorized as a product of the primes, and this factorization is unique apart from the order in which the prime factors occur. Simple idea is from this fundamental theorem of arithmetic is every composite number can be expressed uniquely as the product of the primes. That's all. It means that if you take 12, you know that 12 is a composite number. 12 can divide with 2, 2 6s are 12, 2 3s are 6. So this 12 can be written as 2 into 2 into 3, or 2 to the power 2 into 3. So here you can see that 12 as a composite number, it is written as the product of the primes, and this representation is unique. यसको मतलब चाहिँ 2 to the power 2 into 3 नै चाहिँ 12 हुन्छ. त्यो बाहेक अरु कुनै पनि प्राइमको पावर्स अथवा प्राइमको प्रोडक्टले we cannot get 12. That is the meaning of this unique. And order जुन चाहिँ यहाँनिर भनेको छ, प्राइम फ्याक्टर्स जति पनि त्यहाँनिर निस्केको हुन्छ त्यसको order, apart from that order भनेर भन्नु खोजेको चीज चाहिँ यो हो. So every composite number can be written as the product of the primes. Now next is that what is the sum of the prime factors in the prime factorization of 1728? You know that 1728 is very interesting number. So here, first of all, whenever you will get the question, first thing is that understand the problem, understand the question. Question लाई बुझ्नु एकदमै जरुरी छ. What is the sum of the prime factors in the prime factorization of 1728? Prime factorization भन्दैछ. This problem is related from the fundamental theorem of arithmetic. So first मा हाम्रो काम चाहिँ के हुन्छ भन्दा चाहिँ 1728 लाई प्राइम फ्याक्टराइजेसन गरेर त्यसमा भएको प्राइम फ्याक्टर जुन जुन छ त्यो प्राइम फ्याक्टरको सम कति हुन्छ भनेर भन्दैछ. So 1728, so 2 can divide it. 2 8s are 16, 17, 12 like 2 6s are 12, 2 4s are 8. Now again with 2, 2 4s are 8, 2 3s are 6, 2 2s are 4. Now again with 2, 2 2s are 4, 2 1s are 2, 2 6s are 12. Again with 2, 2 1s are 2, 2 cannot divide 1, so we have to put 0, 2 8s are 16. 2 5s are 10, 2 4s are 8. Again with 2, 2 2s are 4, 2 7s are 14. Now with 3, 3 9s are 27, 3 3s are 9. So this is the prime factorization of the number 1728. Now this 1728 can be written as, how many 2's are there? 1, 2, 3, 4, 5, 6. So 2 raised to the power 6 into 3 raised to the power 3. So this is the prime factorization of the number 1728. Now what the question is asking is, what is the sum of the prime factors in the prime factorization of 1728? अब यसमा मेनली याद गर्नुपर्ने चाहिँ के हुन्छ नि, प्राइम फ्याक्टर जुन जुन यसमा प्राइम फ्याक्टर को हो भन्दाखेरि चाहिँ इट हैज प्राइम फ्याक्टर्स 2 and 3. Here prime factors are 2 and 3. 1728 को factors मात्रै भनेको भए धेरैवटा हुन्थ्यो, 2 पनि हुन्थ्यो, 4 पनि हुन्थ्यो, 8 पनि हुन्थ्यो, 3, 9, 27 थुप्रोवटा नम्बर हामीले फ्याक्टर्स पाउने थियो. तर यहाँनिर के भन्दैछ भने प्राइम फ्याक्टर्स भन्दैछ. प्राइम फ्याक्टर्स आर 2 and 3. नाउ व्हाट यु नीड टु फाइन्ड इट आउट, व्हाट इज देयर सम. So sum is simple, 2 plus 3 which gives us 5. यस्तो खालको क्वेशन्स सर्ट क्वेशन्समा एमसीक्यूमा आउने म्याक्सिमम चान्सेस हुन्छ. तर त्यसको लागि चाहिँ क्वेशन एकदम ध्यान लाएर पढ्नुपर्ने हुन्छ. नेक्स्ट क्वेशन हेर्नुस् ल. What is the sum of the powers of the primes in the prime factorization of 1728? अहिले भर्खरै we have seen that prime factorization of 1728 is, you can see here, 2 to the power 6 into 3 to the power 3. So here the question is that what is the sum of the powers of the primes? What is the sum of the powers of the primes? Look at here, power of the primes are 6 and 3. Therefore sum of the power of the primes is equal to 6 plus 3, which gives us 9. So just see these two questions. These two questions seem same. Thus we have seen prime factors को sum भनेको छ. यसमा prime को power को sum भनेको छ. So answers are different. So these are the questions related to fundamental theorem of arithmetic. यस्तो खालको क्वेशनहरु हामीलाई सोध्ने गर्छ. Next, LCM, least common multiple. So to know the basic concept of LCM, first we will take one example. Let's take the number 10 and 12. So to find the LCM of 10 and 12, before to go into with the methods, पहिला 10 र 12 को LCM भनेको मिनिङ के हो त्यो बुझौं. त्यसमा लास्टमा हेर्नुस् मल्टिपल्स. So I have written multiples. First we'll write the multiples of 10 and 12. Multiples of 10 को, the multiples of 10 are 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120 and so on. Similarly for 12, 24, 36, 48, 60, 72, 84, 96, 108, 120 and so on. So these are the multiples of this number 10 and 12. So from there, what are the common? You can find it out. 60 is there, 60 is there. So one of the common multiple is 60. Another is 120, you can see there. Now if you find it out the multiples of 10 and 12, later on the way you will be getting 180 and so on. So which one is the least amongst this? So 60. So LCM of 10 and 12 is equals to 60. So this is the concept. What actually that 60 means? 60, listen carefully. 60 is the smallest number that is divisible by 10 and 12. It means there is no number less than 60 which can be divisible by 10 and 12. यसको मतलब 60 चाहिँ यति सारो सानो नम्बर हो जुन चाहिँले 10 ले पनि डिवाइड गर्न सक्छ कम्प्लिटली, 12 ले पनि कम्प्लिटली डिवाइड गर्न सक्छ. तर 60 भन्दा सानो कुनै यस्तो नम्बर छैन जुन चाहिँले 10 र 12 दुईटाले डिवाइड गर्न सक्छ. That is the meaning of LCM. Now next we will see the methods. What are the methods that we can find it out, that we can use to find the LCM and HCF? So first method is prime factorization. So we'll take the same example. 10 can be written as 2 into 5. Prime factors. Similarly, 12 can be written as 2 2s are 4, 3s are 12. Prime factors. Just like this. 10 लाई 2 5s are 10 गर्यो अनि 12 लाई 2 6 are 12, 2 3s are 6. त्यहाँबाट लेखेको. अब यसमा just you find it out the common. So common is 2. Then after, to find the LCM, write all the numbers, but whichever will be the paired, for this write only once. यसको मतलब सबै नम्बर लेख्नुहोस् तर जुन चाहिँलाई पेयर गरेको छ पेयरको बदली एउटा मात्रै. It means that first of all I'll write it down 2 into 5 to multiply it with 5. This 2 need not to be written here because त्यसको लागि माथि already लेखिसकेको छ. So this 2 we have to write, this 3 should be written. So 2 5 2 3. So 2 5s are 10, 10 2s are 20, 23s are 60. So this is prime factorization method to find the LCM. Next method is division. The division method is simple. 10 and 12. Find the common factors that divides both of them. 2 5s are 10, 2 6s are 12. Now can you see, do we have any common number that divides both 5 and 6 other than 1? No, it means that the LCM will be 2 multiplied by 5 multiplied by 6. 2 5s are 10, 10 6 are 60. So these are the methods to find the LCM of any two numbers. Next, similarly, we have HCF. HCF full form is highest common factor, HCF, or GCD, greatest common divisor. Now to find the HCF of again any two numbers, we'll take the example 10 and 12 once again. So first of all, we'll start with finding the factors of 10 and 12. So factors of 10, 1, 2, 5, 10. Factors of 12, 1, 2, 3, 4, 6. Because 1 divides 12, 2 11 divide गर्छ, 3 lane गर्छ, 4 lane गर्छ, 6 lane गर्छ, and still one more 12 is also the factor. So these are the factors. So amongst this number of factors of 10 and 12, which are the common? The common factors is 1 and 2. These are the common factors. So in these two, 1 and 2, which is the highest? So highest is 2. It means that HCF of 10 and 12 is 2. So what is HCF? What is this highest common factor? This number 2 is the greatest number that can divide 10 and 12 both. 2 चाहिँ यति सारो ठुलो नम्बर हो जुन चाहिँले 10 लाई पनि डिवाइड गर्न सक्छ, 12 लाई पनि डिवाइड गर्न सक्छ. त्यसले गर्दा 2 लाई HCF भनिन्छ. अब अघिको हेर्नुस् है, LCM मा के भनेको सबभन्दा सानो नम्बर अरे तर 60 आइराको थियो. अहिले सबभन्दा ठुलो नम्बर अनि 2 मात्रै आइराको छ. तर त्यति बेला LCM मा मल्टिपल्स को कुरा हो, HCF मा फ्याक्टर को कुरा हो. सो LCM is the smallest number that can divide by the given numbers, and HCF is the greatest number that divides the given number. I repeat, LCM is the smallest number that is divisible by the given numbers, and HCF is the biggest number that divides the given number. Now here also we will see the methods. So similarly, the first method is prime factorization. So we'll write the same. 10 can be written as 2 into 5. 12 can be written as 2 2s are 4, 3s are 12. To find the HCF, just we will make the common of them. So whichever will be the common, that will be the HCF. That's all. If there exist two numbers, कुनै अर्को number पनि यसमा थियो भने, the product of that common numbers will be the HCF. And division method is, second method is division. For this method, what we need to do? We need to divide the bigger number by the smaller number. In this case, 10 should divide 12. But we know that 10 cannot divide 12 completely. We know that 10 cannot divide 12 completely. Now look at here. 10 ones are 10. Remainder is 2. अब के गर्नुहुन्छ भन्दाखेरि चाहिँ जुन चाहिँ रिमाइन्डर आउँछ त्यसले त्योभन्दा अगाडिको डिभाइजरलाई डिभाइड गर्ने. सो डिभाइजर इज 10. 10 लाई डिभाइड गर्छ. 2 5s are 10. सो रिमाइन्डर इज 0. अब त्यति गर्दाखेरि चाहिँ HCF चाहिँ कसलाई मान्ने भन्दाखेरि राम्रोसँग बुझ्नुहोस् है त. The last divisor which gives the remainder 0. The last divisor which gives the remainder 0. So HCF of 10 and 12 is 2. So concept को आधारमा पनि अघि 2 नै आएको थियो, आउँछ नि त. Methods को आधारमा पनि एउटा method prime factorization is also giving us 2 and division method is also giving us 2. So these are the ways, these are the methods and these are the concept to find LCM and HCF. Now, do you know what is the relationship between LCM and HCF? Simple. First case, LCM of 10 and 12 was 60. HCF of 10 and 12 is 2. So look at here. You just multiply LCM and HCF. So LCM is 60 into HCF is 2. 60 into 2 is 120. Then after multiply the given numbers are 10 and 12. 10 12s are 120. So surprisingly, what we are getting, product of any two numbers are the product of their LCM and HCF. So this is the relationship between this LCM and HCF. You can see here, product of any two numbers can be written as product of LCM and HCF of that numbers. Every time I used to say that more you practice, more you learn. So keep practicing, keep learning. Thank you very much.